R.7 radical expressions. So obviously we're going to be dealing with radicals and like solving them, simplifying them, all the things. So to start with, write each root using exponents and evaluate. We're not, well, yeah, I don't know. 14. The fourth root of 256. So since it says to rewrite it using exponents, this would be 256 raised to the 1/4. So I actually prefer it in this notation, but anyways. When I'm taking the fourth root of something, that means I'm obviously, like taking out like groups of things, like things in groups of 4. And so I like to break down the number that I'm dealing with into stuff that's smaller and then just take things out in groups of 4. So I do a little factor tree. Now, if it's one that I just know off the top of my head, obviously I'm not going to do a factor tree. Like if I gave you the cube root of 8, you would tell me the answer is 2. I'm not going to obviously break that down. This one, though, you probably don't know what the fourth root of 256 is, just off the top of your head. And they aren't all going to be perfect roots either. So sometimes you will end up with stuff left over. And so the only way to really know that is to do a factor tree. So, any guesses as to what I can break this down into? Or like what's one of the like easiest numbers I can use to break this? 2. And what would I be left with? 128. I know, I said the same thing. At first I was like, 125, and then I was like, wait, nope, more than that. So then I want to break down, obviously I can't break down 2 any farther, but I want to break down 128. What can I break this one into? 2
and 64.
2 and 64. And if you see like a bigger number that you can take out of something, like I'll do this for example with 64. I can keep taking out 2s, or I can break 64 into 8 and 8, right? And then from there, I can break those down farther to 2 and 4. And then the 4s break into 2s. So what I'm left with at the end, I have 1, 2, 3, 4, 5, 6, 7, 8 2s. So I take things out in groups of 4. So over here, I have a group of 4 2s, so I'm taking a 2 out. And then over here, I have another group of 2s, so I can take that out. And so this ends up being 2 times 2, which is 4. Now, that one's kind of a lot just because of it being a fourth root and a big number. In terms of the actual breaking down process, normally it doesn't take quite that long to break them down. Have you all done this before? Okay. Let's see. 16. The negative cube root. Nope, I lied. Not a negative cube root. The cube root of negative 343. Helps if you can read correctly. Anyone know this one off the top of your head?
11.
No. If not, we'll break it down. although you may not know. No. It's smaller than that. All right, 343, I need to break that down. However, if you can break down this, if you know what to break it down into, you would know the perfect cube. But
Is it 9?
smaller than that.
7?
Yep, it's 7.
Uh,
So 7 and 49, and then 7 and 7. So I have 3 7s, so I can take that out. But I also need to notice this negative sign in here, so this is actually going to be -7 for that. Now, in 14, we had the 4th root of 256. But what happens if I have the 4th root of -256?
it becomes -4. Becomes positive.
So, if I have an even even root, can I have a negative under the radical? No, I cannot. So when that happens, I have to take an I out. Okay, I is the square root of -1. If you forget, if you look, like, obviously not above my hand, but on this poster above, you'll see that little square root of -1 guy, and the little pi dude is saying get real. That's because that would be a non-real answer. Okay, so this would be equal to 4i, but that is a non-real answer.
I'm confused.
Hmm?
I don't think we learned that last year. We did, but exactly. But
I think this is the only problem in this section like this, and there will be a section later on it. However, the square root of -1 is equal to I. So what I did essentially is just said this is like the 4th root of -1 times 256 to get 4i. You don't need to be too worried about it. There will be a whole section on it later. Just if you see a negative with an even power, so if you see an even and a negative, there's a problem. Basically. But odd, there's not a problem. Why does math work that way? I don't know. Couldn't tell you. Just take it at face value because that's what I was told. Let's see. What's next? All right, the next ones just say, basically, if it's written in exponent form, so like if the power is a fraction, rewrite it in radical form, and if it's in radical form, write it in exponential form. So this is just a rewriting section here. 26, I have in parentheses 5r plus 3t raised to the 4/7. So this is just going to become the denominator of this fraction here is my root. So this is going to be the 7th root. Then I take what's in parentheses, and I'm going to leave it in parentheses and raise it to the 4th power. So the numerator tells me it's the power. The denominator is the root. So this is going to be 5r plus 3t raised to the 4. And make sure you have those parentheses on there because the 4, like it being raised to the power of 4, is going on that whole thing. (30) is the opposite, -m times the square root of 2y to the 5th. So this one's in radical form. They want me to rewrite it in exponential form. So the negative m is outside the radical, so that's going to stay outside. Now I'm going to turn what's in the radical into a parentheses since there's like multiple things there. So that's going to be 2y to the 5th. And then because this is a square root, it's raised to the 1/2. Next one, say to simplify. So if you have something like 36, the 6th root of x to the 6th, what would you tell me that's equal to? X. Because this would be x to the 6 over 6 if I were to rewrite it in that form, which would just become a 1, so that would just be equal to x. You don't have to write that intermediate step that I have there, though, if you don't need, like, if you don't need to visually see it. Um, 38. So same thing, we're just simplifying. We have the 4th root of 81 p to the 12th q to the 4th. So we've kind of got a lot going on here. So I want to break this down as much as possible. And so the way I like to do this is anytime I have a number under the radical, and I know that I'm taking like the root of something, I try to rewrite that number in terms of something else raised to a power to see if it will cancel. If not, you can just do the little breakdown thing. But what to the 4th power, if anything, is 81? I said if any. What does 81 break into? 81, not 18. What did you say? 9 and 9. And 9 breaks into? I have 4 3s. So that means that this would be the same thing as the 4th root of 3 to the 4th power, p to the 12th, q to the 4th. With a 4th root, I can take things out in groups of 4. So what do you see right away I can take out?
6.
How many 3s do I have in here? 4 of them, so I can take one of those out. And that's gone. How many q's do I have? So I can take that out. Now I have p to the 12th. How many sets of 4 is that? 3. So p cubed. I have those letters backwards, but it's fine. So that's how you would simplify that and break it down.
I'm confused. How is it 3?
So you take things out in groups of 4. So there are 3 groups of 4 p's. What's next? Still simplifying the expression, but these are not going to be like perfect roots now. 42. Get the cube root of 250. So, not a perfect cube, so I need to see, excuse me, need to see if I can break it down. So, what can I break this down in?
25 and 10.
25 and 10. Thank you for not saying 2 and 125 because I really wasn't feeling having to branch down a million times on that one side. What is 25 break into? 5 and 5. What about 10? 2 and 5. So I have a cube root. So what do I need to take things out in groups of? 3. So I should have written them in the other order. I have 3 5s and I have a single 2 left over. So I take out a 5. Then I leave the cube root, and whatever's left that you didn't take out is what goes there. So in this case, it's a 2. So 5 times the cube root of 2 would be the answer to this one. $46. I've got the square root of 7 and then times the square root of 5xt. So some rules, in case you haven't done the notes yet, that you need to be aware of. We cannot add and subtract radicals unless they are the exact same. Okay? So if I had the square root of x plus the square root of x, that's not the square root of 2x. That's 2 square root of x, okay? A radical is kind of like when you have a variable and you're doing like terms, you add together what's in front of them, right? So that's how that works. But with multiplying or dividing, I can multiply and divide square roots. And when I am multiplying them, I'm multiplying what's inside of them and putting them all under one singular radical. So this one, when I multiply them together, it's going to be 7 times 5 times x times t, which is just going to be the square root of 35xt. And obviously at times some things will cancel out probably, or you might be able to, once you get to this point, break it down and pull something out. Let's see if I quickly see one that I can do that for. I do not at this moment. But if you could break it down, then you should break it down after that. But do you have to leave early again today?
I do.
Okay. I'm just going to make an assumption that you have to go every Thursday unless you tell me otherwise.
Okay.
Let's see. 50. Negative, and then the square root of 16 over 49. So when I have a radical with a fraction inside, one of the rules of what I'm allowed to do is I can actually break it up into 2 individual radicals. So this would give me, don't forget about the negative. Then on top, I can do the square root of 16 divided by the square root of 49. Now, you do not have to rewrite it. If you just see what this is going to be equal to, that's fine. But if not, then obviously we need to split them up. So what is the square root of 16? 4. And I'm not going to forget that negative. I'm going to throw it out there now. What's the square root of 49? 7. So my answer is negative 4 over 7 for that one. Now, if they're not perfect roots, then obviously there could be a problem. Because we can't leave a radical on the bottom. But let's look at another one. 54. The 6th root of r over s raised to the 6th power. So I'm going to split this one like I did on the last one, just for the visual of it. The 6th root of r over the 6th root of s to the 6th. Can I do anything with the 6th root of r? Good answer. I cannot. So the sixth root of r will stay. What about the sixth root of s to the sixth? Yep, that's just equal to s. So that's where I can leave that answer. Having a radical on top is okay. Radical on the bottom, not good. Let's see, 58. The cube root of 25 times negative 3 raised to the fourth times 5 cubed. So a couple things about this one. Obviously, we're taking the cube root. I've got a bunch of numbers raised to a power. I see a negative sign in there, but I'm not overly worried about it because it's raised to an even power. And if I raise a negative to an even power, what happens?
Stays negative.
No.
It turns positive.
It turns positive. So really the only thing that I need to worry about, I'm not going to rewrite this as like whatever, that value is, but I am going to rewrite this as the cube root of 25 times 3 to the fourth, and then having my 5 cubed, because I don't want to get confused about this negative situation that I have going on and accidentally make my answer negative when it's really not. So cube root means I pull things out in groups of 3. So based on that, what can I pull out of here? And there can be stuff left over inside. Like, you don't have to. I can take out a 5 cubed. What else?
Could you take out the 3?
I can take out a 3 cubed, and what is that going to leave me with inside in terms of that?
3.
A 3. So basically, the 5 cubed is gone. I've taken out 3 of those, so there's 1 of those left. 25 would break down into what? What times what is 25? 5 and 5. I only have 2 of those, so I can't take anything else out. So what I'm left with on the inside is going to be 25 times 3. So out here, oh, that was not supposed to. Hold on. I made a mistake. These are not supposed to be on here because I took out a single one, right? Not a cube of them. I was like, something does not look right. It should not be this big of a number. So yes, you take them out in groups of 3, but you only write it one time. So this gives me 15 times the square root of 75. And that would be your final answer for that one. All right, I'm going to look at 2 more, and then we'll stop there for today, and we'll wrap up the section tomorrow because there's some problems that are a good bit longer that we need to do that we won't get through before Cash needs to head over. So, but it's also a good stopping point just where we're at anyways. So 66 is a radical square root, and underneath it's a fraction. So I've got g cubed h to the 5th over r cubed. So I'm going to split this up top and bottom. I've got the square root of g cubed h to the 5th over the square root of r cubed. So since it's a square root, I take things out in groups of 2. So what am I taking out on top?
G.
A G. What else?
2 H's. H squared.
Yep, H squared. And what does that leave me with inside?
G. And then H.
Yep. And on the bottom, what do I take out?
R.
Am I left with anything inside?
R.
Yep, I'm left with a square root of r. This is a problem. Okay, I can't have a radical on the bottom. Does anyone remember from previous years how I get rid of that?
Square root.
I think I know what you mean, but that's not exactly the term I would use for that. I need to rationalize it by multiplying by the square root of r over the square root of r. Is that what you were trying to say?
In essence.
We'll just pretend that's what you were saying. So what happens here is that by multiplying by the square root of r over the square root of r, it's multiplying everything essentially by 1. But it'll allow me to get rid of that radical on the bottom. And so on the bottom, do that first, r times the square root of r times the square root of r, that would end up inside being the square root of r squared, which is just r. So I'd have r times r, or r squared on the bottom. On the top, I just multiply that r that's in the radical by the stuff that's in the radical on the other piece, since everything's being multiplied. So this would be gh squared times the square root of ghr. And that would be your answer on that one. Any questions on that one? I know it's kind of weird. All right, last one, and then we'll be done for today. And I will go ahead and give you some problems in case you want to get a jump start on them, but we only have a few to do tomorrow, so you should have plenty of time in class. But 74, I have the 4th root of the square root of 25. What's different about this one?
Here's a square root, a square root.
4th root. Anything after 3, we just say like the number, whatever. It's like 4th, 5th, 6th, 10th. Root. So the way I work is just PEMDAS. I start in the innermost part and I work my way out. So what is the square root of 25? 5. So this is going to become the 4th root of 5. Can I break that down any farther? No, I cannot. That's it. A little bit of a trick question there. All right. Any questions on any of this from today? Tomorrow we'll get into performing the operation, so make sure you finish your notes before tomorrow if you haven't already done them. If you want to work on that at this point so you can get those done, that's fine. Like I said, these problems aren't going to be due yet, but the problems to where we are at this point, you have 11, 17, 21, 37, 45, 53, 59, 65, and 73, and I'll add like 3 or 4 more tomorrow to that. Once we get into, essentially we'll be adding, subtracting, radicals, foiling radicals. So if you have like, 2 things in a parentheses multiplied by each other, FOIL those. Some things where we're like multiplying radicals and then dividing by another radical, some things like that. So that's why I was like, this is a good stopping point before we get into all that craziness. So